Good morning. Today in Honors Geometry, we want to study Lesson 7.7-3, Similar Triangles. Recall from yesterday that if two polygons are similar, the following two things must be true. Remember, for two polygons to be similar, all corresponding angles are congruent and all corresponding sides are proportional. Well, today we want to limit our work to only triangles. We begin with postulate 7.1, the angle-angle similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Notice this is different than all the congruence postulates we had in the first trimester because this does not involve any sides. It only involves angles. Take a look at example 1. Determine whether the triangles are similar. If so, we're going to write a similarity statement to it and explain our reasoning. So as we can see, angle O is congruent to angle Y, and angle R is congruent to angle V. So yes, they are similar, because we have angle-angle. So they're similar by the AA postulate. Then we have to write a similarity statement. So that means we have to match up our angles. Angle ROS is similar, triangle ROS similar to triangle VYT. Again, make sure that you match up the angles to their corresponding angles. R matches up to V because they're both 77. O matches up to Y because they're both 65. And S would match up to T because they're the ones that we don't know. Not bad for our first example. Two other theorems about similar triangles. First is the side-side-side similarity. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. And notice it's S, 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 so all three sides have to be shown to be in proportion. 7.3, the side-angle side similarity. If the lengths of two sides of one are proportional to the lengths of two corresponding sides of another, and the included angles are congruent. Again, very important to make sure you understand. The sides must be in proportional, and the angles must be congruent. Then we can prove that the triangles are similar. So take a look at our second two examples. And these are in a table, so you can write your notes right over here to the side, just like I'm going to write mine. Determine whether each pair of triangles is similar. If so, write the similarity statement, and if not, what would be sufficient to prove the triangle similar? Explain your reasoning. Well, as we take a look at number 1, are the two triangles similar? Yes, because we have side, angle, side. Notice that TS would be proportional to XS and RS to WS. That gets our sides in proportion, and angle TSR is congruent to angle XSW because they're vertical angles. We can then write our similarity statement. Triangle TSR is similar to triangle XSW by side angle side. Let's take a look at number 2. Triangle ABC and triangle QPR. Yeah, we'll go with that. ABC and QPR. Well, let's see. Let's go with 8 to 6, 12 to 9, 12 to 9. All we know is sides, so therefore we have to use the SSS. So what's 8 over 6 reduced to? 4 over 3. 12 over 9, 4 over 3. 12 over 9, 4 over 3. So yes, by side, side, side. And then we have to write a similarity statement, so we'll start with this, and I'll go with triangle ABC, similar to triangle QPR. Again, match up the corresponding vertices. Take a look at number 3. Triangle STU. So if I start with S, go up the shorter side, that means I have to go with triangle JPM. Notice we have the angles are congruent. So 10 from this, 15 from the other triangle, 14, 21. So we'll test to see if this works out. So we can reduce this ratio down to 2 to 3. We can reduce this ratio down also to 2 to 3. So yes, these are similar by side, angle, side. Finally, number 4, we have triangle SKM. We'd be looking to compare it to, let's see, we started with the right angle, so we start with the right angle up to the 60, down to the 30, RTQ. Well, we know that these are both right triangles, so therefore this angle, M, must be 30. Angle T must be 60. So yes, they are similar by A. And that's how we use our similarity postulates. So let's move on to our next page of notes. And we can use similar triangles to help us find missing values. Take a look at example 5. Identify the similar triangles, then find each measure. So again, I'm going to write over here. For number 5, are the two triangles similar? Yes. By AA similarity postulate. So we would be talking about triangle EBD, similar to triangle CBA. So that means EB matches up with CB. Again, I need to know the ones that have the X, so CA, well, I should go this way, ED, X plus 5, over AC, X plus 1. And then again, we're going to do our cross products where we multiply the means and the extremes. So that's 15x plus 15 equals 12x plus 60. Take away the 12 and take away the 15. 3x equals 45. That means that x equals 15. But the question doesn't know what x is. They want to know what AC is. So AC is 15 plus 1, 16. And thus we have similar triangles. Let me do this. I'll come back in. Take a look at number 6. Do we have similar triangles first? Well, we have vertical angles here, angle NLM and angle KLM. And notice that we also have parallel lines, which means we can use the fact that angle KGL would have to be congruent to triangle NML because alternate interior angles. So that means the triangles are congruent, are similar, AA similarity, which means that x plus 18, going between the two congruent angles, matches up with x minus 3, and 16 matches up with 4. So again, that's 4x plus 72 equals 16x minus 48. So we'll add 48 and take away 4. And if I do the math correctly, that's 120 equals 12x. We can then divide both sides by 12. 10 equals x. But again, we don't know. We need to find x, but the question wants to know what is JL. And JL is x plus 18. Sticking our 10 in for x. JL equals 28. And again, we can continue on. So again, I'm going to go out and then come right back in. We'll take a look at example 7. Again, same thing. You've got parallel lines, which means you've got corresponding angles here and here, because they're both above the parallel lines and they're to the left of the they're both to the left of the parallel lines, and they're below the transversals here for these two angles. Same thing here. So again, we have similar figures. Now, here's the trick with this one. Obviously, we have HG is similar to FD. For this, we have EG. Well, it's similar to ED, which isn't x plus 5, it's x plus 14. Because again, we have to add this whole side together, so we have to use the angle addition postulate. Then we can cross multiply. 6x plus 84 equals 12x plus 60. Take away the 6, take away the 60. 24 equals 6x. That means that we know x equals 4, and we're looking for EH. Well, if x equals 4, that means that this equals 9. And if we kind of go across from here, we can do this. That makes this whole side is going to be 18. So we have to do another proportion here. 6 over 12. Actually, I don't want to do that. So I've got this, which I don't know. So I got x plus 9. Six over 12 equals x plus 9. Dang it. Hang on, guys, just a second here. 6 over 12 equals x over x plus 9. So 12x equals 6x plus 9. Take away the 6x. 3x equals 9. X equals 3, which means that EH has to be 3. And that's how we use our proportions. Couple more things on our notes today. Like the congruence of triangles, similarity of triangles is also reflexive and transitive. A triangle is similar to itself. If triangle ABC is similar to DEF, then you can flip it around and DEF is similar to ABC. And if ABC is similar to DEF and DEF is similar to XYZ, then ABC is similar to XYZ. Okay. That's our lesson on 7.3. You'll be watching this video here in just a moment, and then you'll be working on your assignment.